Basically, Polygon ID uses zero-knowledge proofs to let users prove their identity without the need of exposing private information. And for us, what that primarily boils down to is that you have freedom of expression and privacy by default, where your identity is secured by zero-knowledge cryptography, and we kind of flip the script on like traditional Web3, traditional models of identity, where our online identities are basically owned by any kind of like a Web2 company or something of that sort. So you could be deplatformed, you could be removed, the data doesn't belong to you, and all of those things. Or Polygon ID essentially restores sovereignty to the users. So let's begin. My name is Tony. I am a DevRel engineer at Polygon, and I am Tony Olendo at Twitter, right? So there's a couple of things here that I've stated about myself. One, I've told you my name. I've told you the position I hold. I've told you my title. I've said where I work, and I've given a attestation that says this is my address at Polygon, at Twitter, right? So these are all self-attestations that I'm making, and we'll see how these things could morph. Everybody makes self-attestations, and identities are very um, it's a very philosophical discussion because when you begin to like delve into the heart of identities, it's basically asking you like who you are, and who you are probably has nothing to do with like where you work or what positions you hold and all of those things. Those are all transient qualities; they could change. Um, and so for us, we're looking at the specific types of like identity that we could put on chain, or rather attestations or like statements about oneself that we could put on chain. So let's say, for instance, I decide to expand that and I say, okay, these are the jobs I've held before. So sorry, this is the type. It should be coordinate. I used to work at Coordinate and I now work at Polygon Labs. I'm saying that these are all technical roles and these are the start dates, right? But this is just me saying this, right? So if you meet me and I say this is what happened, yeah, you have no choice but to believe that. Or let's say that I let's say that I own a dog, and this is my dog. Her name is Zuri. She's really cute. Um, I could say, yeah, I have a dog. Maybe I don't have a cat, and the number of cats I have, or rather, the number of pets I have, equal to. We don't really know whether or not this is true, but this is a statement or an attestation that we often make about ourselves, right? And we could be making all kinds of different statements or attestations about ourselves when we meet people at events such as ETHShanghai. Somebody asks you, "Hey, who are you? Where do you work? Where are you from? I grew up in this place. I live in X city." There are very many things that we say that make up our identity, right? But how do we know if these claims are true, right? So traditionally, essentially, when I present this claim to a potential new employer who wants to know whether or not I had a technical role or something of that sort, they would basically come and begin to contact like my former employers or like verify that information somehow and something of that sort. But essentially, when they do that, they create a VC or a verifiable credential, which are made by a trusted issuer, right? So an issuer is like Polygon Labs. So say they contact the HR department, and the HR department confirms and says, yes, Tony has worked here before. And from there, the my potential new employer now has like a credential that you could say, yeah, this actually checks out. And with the concept of decentralized identity and DIDs, VCs are really, really close to it because they basically are the attestations. They basically claims that you could say, yeah, this is a verifiable credential that is tamper evident and has authorship that can be cryptographically verified. And essentially, they are truths about a particular individual or entity that could be relied upon, right? And the claims could be about anything from what type of job you went to or whether or not you attended a particular event. Something like a Power App could be converted into a VC or something of that sort. And so if you see verifiable credentials, those are really at the heart of what we're trying to do at Polygon ID, and creating a system that allows for like self-sovereign identity, which um, takes into consideration quite a number of different aspects of things. So if I am to go about creating an identity, um, and I choose to use Polygon ID, then first of all, I'll create a schema. So if you look at the top left here, we have the type job held, and then there's just a bunch of strings that I'm putting in that basically um, contain information of who my employer is, whether or not it's a technical role, start date. But this could be swapped out for anything, right? And then you could see now on the right is like verifiable credentials that we could now begin to issue, because we say, hey, yeah, we verify that he works at Polygon, we verify that he worked at Coordinate before, and we could go on and on, right? I could query the Twitter API and find out, hey, who does this account belong to, right? And we could figure out either a complex or simple way that I would tweet something unique that you would then provide as an issuer, and if my tweet contains your specific information, we could then lock that in and say, yeah, for sure, Tony Tony Olendo on Twitter is Tony Olendo, who is making this attestation before us, right? So the various ways we could use verifiable credentials to provide authenticity and reliability on the web, and this could take on very many different things. If somebody's ever bought a domain, there's a bunch of different things you have to do to prove that you actually own the domain. So imagine if, like in a future scenario, you buy a domain and say GoDaddy gives you a VC the moment that you buy it, and you hold that VC in your wallet, and you could just present it to other places, and it's like just immediately accepted. So there are very many applications for this. What about if I say Fido the cat decides to say, yeah, I worked at NASA too, and I have a technical role or something of that sort, right? Is it really reliable? No, because it's a attestation made by a dog, basically. And if you remember, there's a famous meme of a dog saying, "On the internet, they don't know who you are." And this is basically like an extension of that. And this is how broken our current web experience is that you could go on Twitter and create multiple accounts. None of those things are actually verifiable, and we have grown accustomed to a very wild web where identity and ownership is very loosely uh, verified and could not be relied upon. Um, so at the core of this whole solution is the triangle of trust, right? And the triangle of trust is at the bedrock of what we call like self-sovereign identity, and specifically self-sovereign identity just speaks to restoring ownership and control of identities to a user, right? So inside of that, we have the triangle of trust, where there are three primary players. There's an issuer who issues a claim, so this could be anybody. And then there's a verifier. Well, there's an identity holder, and that could be me and you. And the identity holder essentially holds a particular claim, say in a wallet or online or something of that sort, where they have attestations that they hold. And then there's a verifier who comes, who basically receives the proof, and optionally they could actually ping the issuer to find out if um, uh, Fido the cat issued the credential or not, right? Or if Polygon made the attestation about my employment history. So if in a practical example, let's say um, when I leave Coordinate or something like that, so which is a place I worked before, there's a claim that is now sent to my wallet, and the wallet essentially holds that particular attestation. And then when I go to someplace else, I could present it, and the verifier basically doesn't need to know all of the underlying information. They don't need to know like my start date. They don't need to know um, even like different things like you could selectively define what specific information you want that person to hold. And because we're using zero knowledge technology, it empowers what is known as selective disclosure. And selective disclosure essentially just allows a verifier to just write queries. And if the verifier wants to know, A, did Tony hold a technical role? They could actually do that. It goes off, verifies, and it should return. Optionally, there could be communication between the verifier and the issuer. It doesn't have to be the case, but this is still possible. And what we do in that particular instance is that this claim is then pushed on chain, and the verifier and that information is then held inside of the basically a DID is issued for this particular claim, and the issuer could actually specify like an expiry date or something of that. So that says, yeah. So if you look at this, like we could even expand this context up this concept further, and say, sorry, if you hear somebody crying in the background, I have a 3-month-old daughter who is very excited to be attending ETHShanghai as well. But yeah, so the verifier could actually be able to go to the DID that's been issued for that particular VC, and you'll see that whole communication going on. So that's how it kind of works essentially with the triangle of trust. And we have like in terms of the queries, like you could write specific queries where when you're creating the identity, you have a query based request, and it allows basically verifiers to interact with the wallet, and you could set up specific requirements for authentication and all of those things that basically ensure that you have a particular set of issuers that you could enable, right? And the concept of allowed issuers basically uh, locks the particular verifiable credential that you actually create. And when somebody comes to the point of like verifying, you're able to actually lock and say, yeah, for this particular identity, I only want this particular DID of this particular issuer to be able to actually verify that, right? But yeah, if you remember the issuer, the sorting hat on Harry or for Harry Potter um, was actually like a issuer, and it would issue credentials to the students of Hogwarts and would say, yeah, you are going to go to House Gryffindor, and if not, you're going to something else, right, or Slytherin or something of that sort. And basically, once you are part of Gryffindor, there were certain things you could go to the common room. You could become part of the Quidditch team. You could open the magic door. You could become potentially like a team captain. And so, a verifiable credential is something that you could hold and gives you access to various things. If you look at like from a verification standpoint, there's a magic door that you could actually verify and yeah, make sure that okay, yeah, cool, that you are actually a member of Gryffindor, and then it would open, right? And if you, in the context of Polygon ID, if you see the image on the left, you could actually store the information and not necessarily store the actual like name of the house that you're part of, but essentially just store the verifiable credential, and the issuer would be the sorting hat. And so if Hogwarts basically enabled the Polygon ID, all the students of Hogwarts, all they would need would be a Polygon ID wallet that they could carry around, and then from there present it at various places. So that's a high level example of what that looks like, right? We have the Polygon ID wallet app that essentially holds verifiable credentials. It interacts with an issuer to fetch and to store verifiable credentials, and it also interacts with verifiers to share ZK proofed based on those verifiable credentials. And it's a really innovative app because you imagine a single app that actually stores ZK proofs, and we could go into like all kinds of different descriptions and discussions around ZK proofs and how they have to be stored, and like all the optimizations and maybe job signature key pairs and so on and so forth. But essentially, I just want to keep it like in terms of um, when a issuer issues a verifiable credential to the Polygon ID wallet, that proof is held inside of that wallet. And the biggest difference with that is that if you look at how identity models have worked before, is that the user necessarily does not have he has not the final point of truth. But in the context of Polygon ID, like say for instance, you actually go to Google and you create an account. That account actually lives with Google. It doesn't live with you. And anybody who wants to verify that you have a Google account has to interact with Google. But the big difference with this is that now with Polygon ID, that proof that says you're in-house Gryffindor or this is your age or something of that sort now lives inside of your wallet, and you have full control about who uses it, how it's supposed to be used. And as we move into like the days of even more granular um, selective disclosure, you could actually be able to now define different pieces of what that looks like. And this is what it looks like when a VC is issued. So essentially, you would get a ping. So once you actually scan it, you could see, okay, yeah, this is something that is available. So a verifiable credential that says, yeah, you are Polygon at the bit. You accept it. The claim is then added, and it's just and it lives inside of your phone. If you tap it, you'll see the information about that. So you could see, yeah, this was a VC that says that, yeah, you are allowed in Polygon at the pit. You built 420 projects, yeah, 420, issued on a particular date, the issuer, and that's the date for that particular issuer. Does it have an expiry date? No. And the type of proof is a baby job signature. And that's essentially how VCs are held inside of wallets, right? And from a verification standpoint, you could interact with any kind of a service. You could prove your DAO membership. So all you need to do is that the verifier, say a particular DAO or the Magic Door at Hogwarts would basically allow you to connect your wallet, and you then create a request, or Polygon DAO requests a valid membership to prove to membership proof to vote, right? And you could generate the proof inside of your device and then present it. And once it's presented, you could actually see what happens. So you could get any kind of claims or something like that. So if you want to download the wallet, these are the QR codes. I'm gonna give it 1, 2, 3, 4, 5. Okay, cool. Yeah, but you could go to your favorite app store and you could download the wallet and potentially begin to play around with it. And then there's a issuer UI that we actually have an issuer UI where you could do like a KYC age credential and say that you have to be older than 13 to use the social media app, or you have to be younger than 18 to sign the yearbook or something of that sort. So this is information that kind of like exists. Or you could do like the KYC country of residence credential that says, hey, you want to geo fence an app? Sure, using that. Those are features, right? But the only thing that we're storing is your country of residence. But from a verification standpoint, these are the various scenarios that you could do without ever revealing which country you live in, right? So let's say you built an app that has specific conjugated voting for a particular election. Nobody would ever have to know who tried to access the app that is or isn't a citizen. The only proof that will be generated would be, are you a member, or are you a citizen of that particular country, right? You could think about in terms of resident chain coupons, all kinds of different applications that we could build using ZK at the core of it, and it becomes like a fairly simple thing. And if you set up the demo issuer, the UI, then it becomes like a really easy way for you to get started with that. There's also the issuer node, which fairly complex. I kind of enjoy. I actually have a video. I forgot to link it here, that shows you how to set up the issuer node, and it's really useful. Um, and you could actually go and look at that from there. You have the code, you have the docs, you have like the whole setup, and I'll probably tweet um, or something like that, or to try to send the the information there about the issuer node later. But we have a whole setup there that makes it possible for you to um, makes it possible for you to actually set up your own custom issuer if you want full granular access and control. So you could do like the Polygon ID wallet mobile app that this is essentially how it works. So you could set up either the easy demo issuer or the self-hosted issuer node, and from there you could participate in that whole ceremony of triangle of trust, where you could create a wallet with the Polygon ID mobile app, and then create a claim and store it in the Polygon ID wallet, and verifiers could then interact with it. So there's a really cool repo that Steph built. So shout out to Steph, which shows you how to build like a VC gated app using a verifier app. So basically, you could build like a secret app. So you have a VC gated website, and VCs in this context, again, just for context, are verifiable credential gated app, and it makes it easy for people to just like clarify. Okay, so this is how we could do it using VC. So you could set up the app to be like, hey, prove you were born before 2023 to view, right? So my daughter wouldn't be eligible, but potentially other people in the room should be, right? And so you're able to actually verify things in that way. Or you could do like the full age credential. This is a fairly straightforward um, um, credential where we basically create the credential. There's an auth reason that you specify. You say the birthday, the users must be less than, so the LT less than 2023 0101, and then from there you're able to create like the credential, and you pass in the credential subject, and the proof request is what you then send back to the user, and then it becomes like a fairly straightforward process. So this is the link to the VC gated app template on GitHub. If you want to go check that out, you are free to do so. And essentially, basically, just enables you to have like a full dApp experience using the VC gated app. So yeah, that's it. So thank you very much. I don't have much else to share, um, but I hope you enjoyed it. And I don't know, I feel we might have time for some questions. Or we have 4 minutes, so I'm hoping you have time. Yeah.
All right, thank you, Orlando. And I think we are pretty much approaching the lunchtime, and I want to again, express my gratitude for your talk. Really excited for the future application of Polygon ID.
Okay, great. Thank you very much.
All right, thank you so much, Orlando. And I think we want to wrap up the East Shanghai Day 2 morning session. And I think everyone will have 1 or 2 hours lunch break, and later on we'll have our very own Duan Shao to take over the afternoon panels. Thank you all.